All right, let's talk about something that is just fundamental to all of programming, loops in Python. If you've ever wondered how you can get your code to do something 100 or heck, even a million times without writing a million lines of code, well, you are in exactly the right place. Let's get into it.
So here's our game plan. We're going to start with why we even need loops in the first place. Then we'll build up our toolkit with the two big ones, for and while loops. After that, we'll see how to smash them together and finish up with some really cool techniques to get total control. Okay, first up, why do we even need loops? It all comes down to solving the problem of repetition. So let's start with a really basic question. Why even bother with loops? Well, they're here to solve one of the biggest headaches in coding, just pure repetition. Think about it. What if you had to print hello 100 times? You could copy and paste, sure, but what about 1,000 times? A million? There has to be a better way, right? And that better way is, you guessed it, loops. They are Python's super elegant solution for automating all those repetitive tasks. They make our code cleaner, way shorter, and just so much more powerful by basically telling the computer, hey, you handle the repetition for me. So this brings us to our first major tool, the for loop. You can really think of this as the workhorse of Python loops. Anytime you have a bunch of items, a list of names or range of numbers, and you need to do something with each and every one, the for loop is going to be your best friend. And the magic word here is sequence. A for loop is specifically designed to step through a sequence of items, one by one, from the beginning to the end, and run a block of code for every single item it finds. Let's look at our really simple example. This code is basically telling Python, hey, for every number, let's call it I, that you find in the sequence from 0 up to, but not including, 4, just print out that number. And that range function, it's just a super handy shortcut for creating that sequence of numbers for us. And there's the output, 0, 1, 2, and 3. Now, this shows a really important detail about range. It always includes the starting number, but it stops before it gets to the end number. That's a classic Python thing, and it's super important to remember. But for loops are not just for numbers, not at all. Their real power is just how flexible they are. You can use them to walk through items in a list, characters in a string, even keys in a dictionary. Basically, if you can count it, you can probably loop through it.
Okay, time for our second tool, the while loop. If a for loop is all about going through a sequence you already know, a while loop is about repeating something as long as a certain condition is true. The logic is literally in the name. While this thing is true, keep doing that thing. It's not about a fixed number of items. It's all about a truth test that the loop performs before every single run. So here's how it works. We start a counter, CNT, at 0. The loop's condition is, keep going as long as CNT is less than 3. Inside the loop, we do two things. We add 1 to the counter, and we print hello geek. And this just keeps repeating until that condition isn't true anymore. And what do we get? Exactly 3 hello geeks. So, why? Well, first time through, 0 is less than 3. Yep. Second time, 1 is less than 3. Still good. Third time, 2 is less than 3. Great. But then CNT becomes 3, and the condition 3 is less than 3 is false. So the loop just stops right then and there.
So here's the big takeaway. You use a for loop when you know exactly what you're iterating over, like every single item in a list. And you use a while loop when you need to repeat something an unknown number of times until some specific condition happens, like, say, waiting for a user to finally type quit. All right, now that we have our two main tools, let's look at how we can put them together. It's called nesting, which is really just a fancy word for putting one loop inside of another one. Now, understanding the flow here is absolutely key. For every single time the outer loop runs, the inner loop inside of it will run through its entire cycle from beginning to end. Then, and only then, does the outer loop get to move on to its next step and kick off that inner loop all over again. Let's look at this code. We've got an outer loop that counts from 1 to 4. Now, for each of those numbers, an inner loop runs that many times. So when the outer loop's I is, say, 3, the inner loop runs 3 times. See that indentation? That's how Python knows which code belongs to which loop. It's super important. And this pattern just shows the concept perfectly. The outer loop is basically controlling the rows. It decides what number we're printing. The inner loop is controlling the columns. It decides how many times that number gets printed on a line. This is a really fundamental way to create patterns or work with data in grids and tables. Okay, last section. Let's look at how we can get even more precise control over our loops. Because, sometimes you don't want to just run a loop from start to finish. You might need to change its behavior right in the middle. And Python gives us three main statements for this: continue, break, and pass. So continue basically says, skip the rest of this round and just go to the next one. Break is more dramatic. It says, stop everything right now and just get out of this loop completely. And pass, it's just a placeholder. It literally does nothing.
So imagine you're looping through the letters in Geeks for Geeks. If you hit an E or an S, continue tells the loop to immediately jump to the next letter, completely skipping the print command for that one iteration.
Now, break is much more final. In that same situation, the moment the loop sees the very first E, the break statement runs, and the entire loop just terminates instantly. The rest of the string, it never even gets looked at.
And one of the sources for this explainer put it perfectly. Loop control statements change execution from their normal sequence. That's the best summary right there. These statements let you bend the rules of the loop, giving you this amazing, precise control to handle really complex situations. So there you have it. We've covered the why, the two main types of loops, how to combine them, and how to take full control. You now have this incredibly powerful set of tools for automation and for solving problems in Python. So the only real question left is, what are you going to build first?